All right. Here we go. So again, we're going to solve this inequality. Now, so what I did was this. As you can see, again, you don't have to do the exact same steps in the exact same order, but you do have those manipulations. I mean, the examples I'm giving here, I mean, they're okay. The only thing is, though, is that every time, as you can see, we have to multiply or divide by a negative, which is not terrible, but, you know, it's just, you just got to remember that you only turn the inequality around when you multiply or divide by a negative. So for instance, here we have minus 10 on both sides, right? That gets the 10 out of here. So we have negative 5x on the left, 3x over here, plus 3. So this is what we have. Now, I want to get x all alone, so I subtracted 3x from each side, as you can see. We get negative 8x less than 3. Okay. Then from here, we have negative 8x less than 3. So again, we divide by negative 8. And we turn the inequality around to get this. It's just that in the other class that came up, someone asked, do you always turn the inequality around? You only turn it around when you multiply or divide by a negative. So if for some reason we did positive 8 here, we would not have turned this around. Oh, okay. You know, I will post the notes, of course. So we have this. And we have our solution set, which again is minus 3 over 8 to infinity. I also graphed it for fun, as you can see. Okay, good. Again, go back x greater than minus 3 over 8, right? So we want all numbers bigger than 3 over 8, and that's what this is. Beautiful, good. Okay. All right, so that works. Now, that's for our single inequalities, okay? Are there any questions on that? Okay. For compound inequalities, okay, then it's similar. The only difference with compound inequalities is you're solving two of them at once. And what you generally want to do, and what you want to do is get x all alone in the middle between both inequalities. So for instance, if we're looking at this one, right? We don't want x plus 5 in the middle. We want x all alone in the middle. That's what we want. How do we do that? Well, that's actually pretty easy. For this example, you basically just subtract 5 from each side. Again, whatever you do to one side, you do to the other. You know, that's one of the manipulations. You know, whatever you add or subtract from one side, you do to the other. So we get this. Okay, so we have negative 2 less than x, less than negative 1. Again, basically from here, we just subtracted 5 from each side. So 3 minus 5 is negative 2. X is in the middle. That's good. X is all alone in the middle. 4 minus 5 is 1. Boom. That's good. And to graph it, we have that solution set, negative 2 to negative 1. That's our graph. Again, remember, from here, we're not including the endpoints, which is why the circles are open. Okay, good. Like, that's one example. Okay, let's do another one. I was going to have you guys try this, but for the other class, I skipped over having them try it. Not to say they couldn't do it, but I was worried about time. So let's do it. Let's do it together, okay? All right. So here we want to solve this inequality. So what do we want to do is we want to get x all alone between the two. And I know there's a mistake here over here. Let me just fix that. Namely, 3 minus 5 is not -1, it's -2. So let me fix that. I think that, now if I'm right, that's the only mistake. There we go. Beautiful. So this is what we have now. So again, 0, right, less than 5 minus x over 2, less than or equal to 3. We want x all alone. So let's get the 5 out of there by subtract. And we end up with this. -5 less than -x over 2, less than or equal to -2. But again, we want x all alone, right? So what are we going to do? Well, we can multiply both sides by -2, right? By doing so, we'll get x no. But we also have to turn the inequalities around, which I do here. Right? So here we have -2 times -2, -2 times -5, we get this. So our solution set, that should be a 4. Let me fix that. That's a 4. Like so. 4 is less than or equal to x 10. Then we have our solution set, which again should be 4 on the left. And so on. There we go. Beautiful. Good, good. So that's what we get. So again, here also, x is greater than or equal to 4. So that's why the closed circle is above 4. 10, we have 10 we're not including because of the strict inequality. So we have parentheses. And we have an open circle above 10. Okay, so that's what's happening here. And now, I'm not sure if it's in 1.5. They do quadratic inequalities, I think, in 1.5, but I'm going to skip that. So what I'm going to do now is move on to 1.6. So let me just let me do that. Okay, let me just share that. Okay, and again, these are in the notes I sent you. Wait, hold on, there we go. And now we're at the beginning. Okay, so here, what we're going to look at, as you can see, is we're going to look at inequalities again, but now we're going to consider absolute value and equations as well. So that's what we're going to look at here. Okay, so that's what absolute value we're going to look at. Now, I'm not sure if you've seen absolute value. What I am going to do is give you the whole definition. I'm also going to show you another way to look at it. You know, sometimes, well, you'll see what I mean. So here, so B is any number. So this is the definition of absolute value. For any number B, the absolute value of B, denoted by this, by definition, it's given this way. It's actually what they call a piecewise defined function. This is just saying the absolute value of B is B itself if B is non-negative. So the absolute value of B is B itself if B is non-negative, and it's negative B if B is negative. So if B is non-negative, you get this. If B is negative, you get this. That's how absolute value is defined. Okay, that's good. All right, now let's do an example. For instance, if you have absolute value of 10, right? Well, 10 itself is non-negative. So we're just going to get 10 back. If you had the absolute value of -1, well, -1 is negative, So we're going to get back negative 1, which is 1. I mean, hopefully, since negative 1 is less than 0, hopefully we can see from these examples that the absolute value of a number is non-negative, right? It's giving you back the number itself if it's non-negative. But if the number is negative, you're putting a negative in front of it. And if you negate a negative, you get a positive. To make it a little bit easier, let's look at this in another way. We can think of absolute value as distance along the number line. So in other words, the absolute value of that number b, whatever it is, it's going to be its distance along the number line from 0. So here, right, the distance between b over here and 0, well, that's just b, right? Because b is non-negative. So the absolute value of b is b itself. But now negative b is negative, but this is also b units from 0. It's just b units to the left. Okay, it's just b unit to the left, but its absolute value is also b. Again, that's because it's b units from 0. Sometimes in math, you have to do that. You have to look at something from a different point of view, and then you get some kind of, what's the word? And then you can see what's happening. You get a very nice point of view. And you'll see that with, I'm not done yet, but you'll see with absolute value, think of it as a distance. That makes things a little bit easier.